Hey there, let's talk about analyzing the secure reliable transport protocol with Wireshark. Wireshark is a great free and open source tool to analyze network traffic, to go deep to bits of every packet. Visit wireshark.org to get more info if you're not familiar with it. On the other hand, there is SRT, an awesome free-to-use and open-source network protocol for ultra-low latency live streaming. Check out the SRT protocol overview video on this channel if you want to get yourself familiar with it. There is also an internet draft for the protocol if you really want to go deep into specs and see how the packets are formed and so on. Back to Wireshark. Starting from version 3.0, Wireshark can dissect SRT packets. The support for the secure reliable transport protocol has been introduced in this version of Wireshark, while the latest version is 3.6 something, so if you just grab the latest one, you have support for SRT there. There is also a dedicated page in the SRT cookbook. Please find the link in the description below. Some parts we will be talking about today can be found there. We will skip the installation part as it is pretty easy. Some bits are described in the cookbook, but all the latest information can be found on the wireshark.org website. Alright, you have Wireshark installed and ready to go. Now let's configure it. First of all, go to Analyze Enabled Protocols. Here we need to find UDT protocol and disable it. UDT is a custom file transfer protocol not really used today. SRT is based on UDT, so Wireshark can get confused. If you disable UDT, it is much easier for Wireshark to recognize SRT traffic. After disabling UDT, please also ensure the SRT protocol is enabled. Another useful thing is located in Wireshark Preferences. Go to the Advanced section and find udp.try_heuristic_first. Some hardcore details you probably don't need to know, but setting it to true enables passing a UDP packet to subdissectors first. SRT is a subdissector of UDP, and there might be some rare cases when Wireshark will not pass the remainder of the UDP packet to subdissectors and SRT will not be automatically recognized. Let's see how to capture network traffic using Wireshark. With SRT it would be easy if you start capturing before the SRT connection has been established. Then handshake packets would be captured and Wireshark could automatically recognize SRT traffic. No worries if you don't have those very fast packets though, we will still be able to dissect it. First of all, select the network interface to start capturing on. In my case it will be Wi-Fi, so I just select it by double-clicking on it. I already have the SRT as a display filter so that only SRT packets on this network interface are shown by Wireshark to not show you all the traffic that I have here. And I'm starting SRT transmission now. It will be 10 megabits per second SRT live streaming for the duration of 10 seconds. You can stop at any time you want. In my case, I just wait for an SRT shutdown control packet to have the whole capture of my stream. I have it and now I am stopping the capture. Then you can save it and open it anytime to do the analysis. What to do when Wireshark does not auto-detect SRT and shows you UDP packets instead, but you are sure you have SRT capture. Right-click on one of the packets and go to Decode As. Wireshark automatically adds UDP ports of the packet to the list and you just need to select to decode packets on this port as SRT packets. Now Wireshark will force apply SRT dissector on these packets, even if they are not SRT. A good indicator of valid SRT stream is to see a bunch of data packets, followed by an acknowledgement packet. And a double acknowledgement packet, which is acknowledgement of the acknowledgement. Now, a distance between consecutive acknowledgement packets should be around 10 milliseconds, like in this case. Here we have the first acknowledgement coming at the 17th millisecond, and the next one comes at the 29th millisecond, so roughly 12 milliseconds or around 10 milliseconds. When you have this in your capture, it's likely an SRT stream. Once you have your SRT stream captured, you can see packet dissections in Wireshark. There are different types of packets in SRT. Already here you can see control packets, data packets. Obviously data packets carry payload, and you can also see them in Wireshark in the data field. All types of packets can be found in the SRT IETF draft. So in the section packet structures, you can see two major types, data and control packets. If you navigate here, there is a general form of SRT packet structure, and the very first bit of the packet defines whether it is a data packet or a control packet. So if this bit is set to 1, then it is a control packet. If it's set to 0, then it's a data packet. So in Wireshark we can also make use of this field. We can find it here and see in the bottom that it's SRT.isControl, and this way we can filter out, for example, control packets. So SRT.isControl equals 1, and we see only control packets in this capture, or equals 0, and we see only data packets in this capture. Now, control packets have more types, so the general structure is quite the same. The very first bit is 1, and it is followed by the control type field. This control type field defines the actual type of the packets. There is a table with the control packet types, so it can be a handshake, keep alive, acknowledgement, loss report. So basically acknowledgement and loss reports are the main type of packets you would that might be useful for you, and also drop requests sent by sender. You can read about these packet types in the description. So for example, let's take loss reports and go to section 3 to 5 to see the packet structure of the loss report. Basically the heading part is the same, as all packets have the control information field. In this case, instead of payloads, as it would be for data packets, it contains loss records. So one or several loss records. It can be one packet sequence number or a range of packet sequence numbers. So let's try to find this control type, this control packets in our network capture. So first of all, let's see the control type value for this packet. It's 3. Now we can filter this type of packet. So in any control packet, I can find this type field, and it is it can be referenced by SRT.type. So SRT.type equals 3, and we see all loss reports that are captured in this session. In this case, we see the loss report record in the range of packet sequence numbers from something 967 to 073. So it's a range of packets being reported lost, and it means that those packets will eventually be retransmitted. Now if we delete this filter, we can still be located for this on this loss report and see the data packets being retransmitted. So the very first is 967. So in this case we see acknowledgement packets coming right after loss report, and this acknowledgement packet actually acknowledges all packet sequence numbers up to 7138. So including packet sequence numbers from the loss report means that either receiver has dropped those packets as too late to be delivered, or it has actually received it out of order, but I would bet for the dropping. So we can also find next packets by searching for the type 3. This loss report reports packet sequence number 926 and acknowledges only 908. It means that we should have retransmissions, and there we have it. So we have this retransmission flag set to 1, and in this bottom field we see srt.message.regsmith, srt.msg.regsmith equals 1, and by filtering these packets we can see only retransmission packets. So there is a lot, mainly from the second to the 4th second, And to better visualize it, we can plot a graph in statistics IO graphs. Here we can also use the same filter types defined previously. In this case, I already have them set. So SRT is control equals 0, and we set y-axis to bits and retransmitted packets. So srt.msg.retransmit, and also calculate bits. Let's change the color a bit. Let's say retransmitted will be red. Now we can better see it. So we see that most retransmissions happen from the second to the fourth second, and all in all, data packets of make 10 megabits per second stream. We can also check how many original packets are here. In this case, we need to also specify original packets, which would be srt.msg.retransmit equals 0. So only original packets. So this would be original one. So a bit more straight line. Here we have retransmission goes on top. There you have it, folks. Now you know how to capture SRT using Wireshark, how to dissect SRT packets using Wireshark. Now, if you really want to go deep into understanding how SRT works and what each field of the packet means, you can really consult with the SRT protocol internet draft. It has a dedicated section called packet structure. Here you can find all the packets of SRT. You can find the field you want to read about. You can find description on this field, maybe some reference to a related section like here with timestamp reference in section of data transmission modes, with message mode and buffer mode, each further reference in some other stuff. I hope you enjoyed. Stay tuned for more videos in this channel and hope to see you soon.